Alright guys, we're going to get started here right away, skipping warm-up because we've got a short class. I want to make sure that we get in what we need to. And so this isn't anywhere, I just want to do a quick discussion about it. Eventually, by the end of the unit, you'll have learned 4 shapes, and I need you to be able to figure out which shape is which without seeing them in their standard forms. So right now, they're all jumbled up, not in standard form, not in what it looks like. So you don't see any parentheses, so it's not easy to find the center or anything like that. So the way that you tell something is, let's say, a parabola. A parabola is the easiest one to spot. A parabola only has one squared term. If you remember before break, we only had to complete the square on one side of the equation for a parabola. And so the parabola of all of these is the one with one squared term. So you can see A has only an x squared, but B has an x squared and a y squared, and C has an x squared and a y squared. So the parabola has to be A. The way to tell a parabola is there's only one squared term. Eventually, you would manipulate this equation to look like the standard form of a parabola. So we would complete the square on one side, and then we GCF on the other. So we get that like 4P look that we talked about before break. All right? The other 2 shapes we learned were a circle and an ellipse. The way to tell the difference between a circle and an ellipse. A circle is divvied out evenly. Left, right, up, down, right? The radius is the same. Whereas with an ellipse, the radius is different for its width than it is for its height. So if you look at this, see how the squared terms here have the same coefficient, the same number in front. And the squared terms here have different numbers in front. This is going to be stretched differently based on its x and y, whereas this is going to be stretched the same. So that means that this one is an ellipse, while this one is a circle. A circle can have numbers in front too, like if this was a 4 and this was a 4. That's still a circle, right? So it can have numbers in front. The numbers in front just have to be the same coefficient. So the squared terms have the same coefficient for circles, whereas for ellipse, the squared terms have different coefficients. Everybody okay with that? So really, really easy multiple choice question. It's going to be like, what shape is this? You're going to be able to hopefully by the end of the unit look at it and tell which shape it is. So today what I want to do is be able to take you from what's non-standard form of an ellipse to make it look like standard form of an ellipse. And remember, you don't have to memorize this. You'll be given this. So I want you to look at something like this and be like, it's got to be an ellipse because it's got 2 squared terms, so it can't be a parabola. And the coefficients are different, which means the stretch on the x is going to be different than the stretch on the y, which is going to give it more of an oval shape than a circle. If this was a 9 and this was a 9, now I want to make it look like a circle. You okay with that? So this is what the standard form of an ellipse looks like. We want to get it to that point, all right? So, in order to do this, this is in your toolkit. I'm not exactly sure which page. I don't even know if your toolkit has pages at this point. But it's at the bottom or the next page of what we did yesterday. So you can find that ellipse section. I think we were on page 3 yesterday. Obviously, to get this x minus h squared, y minus k squared look, we're going to have to refresh our memory on that complete the square method. We're going to do that again. We're going to do it twice. We're going to do it for the x and we're going to do it for the y. But now we're going to have some fractions, which kind of complicates things a little more than normal. So here's what I'm going to do first. I'm going to rearrange this so that my x's are together, my y's are together, and my non-y's, that plus 36, is going to go to the other side of the equation. So all I want on the left-hand side are the x's and the y's. So that plus 36, I'm subtracting, I'm moving it to the other side. It's page 7 of the toolkit. all right? Now, from here, what makes this different than a circle is there's this coefficient of 9. Every time we've completed the square, it's been with just x squared or just y squared, not 9x squared. I need to get rid of the 9. So what I'm going to do is factor it out. I'm going to divide each of the x terms by 9 so that I've factored out a 9 and I'm only working with an x squared. But if I do that to the first x term, I have to do it to the second one too. So I'm dividing 9 out of each of them, all right? So this becomes, in other words, if I were to redistribute that 9, I'd still have 9x squared and 36x. I'm not changing the problem, I'm just factoring out a 9. Everybody okay with that so far? All right, and then before break, we learned this process of completing the square, where we put a number in that blank, and that number's always a perfect square. Anybody remember how we get it? The same step every time. It's been a while. It's been over a week since you've had to get that number.
Don't you divide by 2 and then square root?
Divide it by 2 and square. So we're going to divide this number by 2, and square that number, 4. So my perfect square here is a 4. We okay with that so far? All right, now we want to do that same process to the y's. I don't want a 4y squared, I just want a y squared. So I'm going to divide a 4 out of each of these. I'm factoring out a 4 so that I'm only looking at y squared. Negative 24y divided by 4 is negative 6y. And then I want to complete the square with that as well. So like Mahari said, I'm going to do negative 6 divided by 2, negative 3 squared. My perfect square is 9. On the other side of the equation, we have a negative 36. But remember, if you add these two numbers to the equation, like this 4 and this 9 weren't part of the equation. I just threw them in there. So if I'm just going to throw them in there on the left, I have to do it on the right too. But here's the tricky part. It's not really a 4. Any guesses on what it actually is?
2.
No. That's if you factor it. I'm talking about is what is that value really?
Root 4?
Nope.
36.
36. Why?
Because you're multiplying it by the...
Think about that 9 still there, right? So this isn't really an x squared, it's a 9x squared. This isn't really a 4x, it's a 36x. This isn't really a 4, it's a 36. So I'm not adding a 4 over here, I'm adding a 36. This isn't really a 9, it's a 36. It is very coincidental that they're all 36s. They are not always all 36s, okay? So they don't always match. Like sometimes this could be 100 and this could be 52. Like it just depends on the problem. They're not always all the same number, all right? Just keep in mind that the number that we have here needs to be multiplied by that number in front. And now, Gary, you were getting to the part where you factor it. That's where you were saying the 2. So at this point, I can factor this. It's a perfect square trinomial. So what multiplies to 4 and adds to 4? 2 and 2. So this is x plus 2 squared. We're starting to get to this point. We've got the x minus h squared part. And here, what multiplies to 9 and adds to negative 6, negative 3 and negative 3, you might remember from before break, we always just drop the symbol down and cut that number in half. So I'm dropping the minus down and I'm cutting that number in half. And then on this side, negative 36 plus positive 36 plus positive 36 is 36. Now if this were a circle, we'd be done, but it's not, it's an ellipse. And an ellipse, this side of the equation, the right-hand side equals 1. And the left-hand side has fractions. So can anybody think of a way that I could make this equal 1 while making this side a fraction? Divide by 36. So if I do this, 36 divided by 36 is 1. But if I divide on the right-hand side, I have to divide on the left-hand side too. So I'm going to divide each part by 36. And now the last thing I have to do is simplify my fraction. So like 9/36 and 4/36 are fractions that you can reduce. If you don't know how to do that in your head, you can always do it here in your calculator, like 9 divided by 36, math, enter, enter. 4 divided by 36, math, enter, enter. You don't have to write the 1. So we'll have a 4 on the bottom of the first one and a 9 on the bottom of the second one. So my standard form ends up looking like this. X plus 2 squared, 9/36 was 1/4. I'm not writing the 1 on the top, I'm just writing the 4. So that takes care of the first part, plus y minus 3 squared, 4/36 was 1/9, I'm just not writing the 1, equals 36 divided by 36, which is 1. Now I have what's called standard form. Now it looks like this. And then yesterday we learned how to graph that. So the center is opposite of what's with x, opposite of what's with y. And then yesterday we learned about, is this going to be a wide ellipse or a tall ellipse, right? So the radius in the x direction is 2, and the radius in the y direction is 3. So this is going to be pulled more tall than it is wide, which means the main axis is the tall axis, which is the y axis. This is going to be a tall ellipse. And then we learned that a is always the square root of the bigger number, right? A is always the biggest. So a is going to be the square root of 9, whereas b is going to be the square root of 4. And then we learned yesterday how to solve for c. So it was using this formula, a squared equals b squared plus c squared. And you work your way through and solve. You ultimately end up with the square root of 5 for that c. We talked about yesterday how we plot the points to get all of those things. All right, but really all you're doing here is completing the square to try and make it look like this. So I was thinking I'll do one more with you and then have you do one, and then that'll be the class because it's really short stuff. So second example in your toolkit looks like this. It's an ellipse. It's an ellipse because there are 2 squared terms, which means it's definitely not a parabola. And the coefficient on those square terms are different. If they were both 5, then I'm looking at a circle, okay? And knowing what the shape is tells me what ultimately I'm trying to get it to look like. So an ellipse looks differently than a circle does in terms of its standard form. All right, so first thing I'm going to do is I'm going to put my x's together. And you don't have to do this step if you don't want to, but because it's new notes, I'm doing it. So I'm putting my x's together. I'm putting my y's together, and I'm going to add that 39 to the other side, since it doesn't have an x or a y with it. All right, from here, I would factor out the leading term, but see how the x doesn't have one? I don't have to do anything, so I'm just going to complete the square for that one. I don't have to factor out any coefficient in front because it's already x squared. So what's my perfect square that goes in that blank? 16. Now for the y term though, we're going to have to divide out of 5 from the 2 y terms because I only want it to be y squared, not 5y squared. So I'm dividing out of 5 from each of them, which is going to give me a minus 6y. Which means my perfect square is another 9. So on the right-hand side, we have the 39 from the beginning. We have the 16, but that's not really a 9. What is it?
45.
45. 5 times 9 gives me a 45. So what do we got for this side? 39, 16, 45. 100. All right, so we've got, if we factor this, I'm bringing down the minus, I'm taking half of that squared, so we've got x minus 4 squared. The 5's still there for now. I'm bringing down the minus, half of 6 is 3 squared. And then when I add 39, 16, and 45, I get 100. If this were a circle, we'd be done. That's what a circle looks like. The circle stops at that step. We'd say the radius is 10, and we'd have the center, and we'd be able to go in all directions. But since it's an ellipse, I need it to equal 1. So to make this equal 1, I divide by 100. There's no fraction to simplify here, right? There's no number in front. So this part's just going to stay the same. But for this part, I want to reduce this fraction. So this 5 over 100 reduces to 20. 5 divided by 100, math, enter, enter, equals 1. And then this is the standard form of your ellipse. Your center is opposite of what's with x, opposite of what's with y. Your radius in your x direction is 10, and the radius in your y direction is the square root of 20, whatever that is, but it's definitely going to be smaller than 10, right? So because 100 is bigger than 20, this is going to be bigger in the x direction, and so my major axis is the x-axis. This is going to be a wide ellipse, so like more like this. A is always the biggest number, so the square root of 100. B is going to be the square root of 20, and we normally would write that as a decimal just to estimate it, but you could also break it down to 2 root 5. And then C is going to be the square root of 80 if you go through and solve it using that formula. And we could break that down too. All right, so we're out of here at 59. So I think that's plenty of time to get you. I just wanted you to try one before you head out. So you guys try this one, and I think I'm going to post the answer. And we'll call it a day. All right, so you're trying C. Make sure you can do one. I have all freshmen math help tomorrow. Thursday is home base, but if your home base teacher doesn't care, I don't.
Yeah, he wouldn't care.
Then that's fine. You can
That's,
get that.
yeah, I wasn't doing instruction.
Yeah, you can come. You can come Thursday.
Okay. It's fine. We went for Thomas, we went for,
Wait, pause.